Welcome to the Bare Metal Cyber Security Plus podcast. This series helps you prepare for the CompTIA Security Plus exam with focused explanations and practical context. For a companion study guide, check out the Achieve CompTIA Security Plus 701 Exam Success by Dr. Jason Edwards. It is the most concise and complete Security Plus guide on the market, built for busy professionals who want to pass the exam fast and on their first try. You can find this book and others at cyberauthor.me. In this episode, we are looking at two major categories of vulnerabilities, those found in operating systems and those found in web applications. These weaknesses are commonly exploited by attackers and often serve as entry points for larger breaches. Understanding how these vulnerabilities work, how they are discovered, and how they are mitigated is essential for both technical defenders and cybersecurity decision makers. Let's begin with operating system-based vulnerabilities. Operating systems are foundational software platforms that manage hardware, run applications, and support user interaction. Because they serve as the control center for all activity on a device, they are also frequent targets for attackers. Common operating system weaknesses include poor access controls, misconfigured file permissions, weak or default credentials, and unpatched software. Attackers often look for privilege escalation flaws, vulnerabilities that allow a user with limited access to gain administrative control. Other attack techniques include exploiting remote desktop services, buffer overflow bugs in core system processes, and bypassing authentication controls through exposed APIs or legacy protocols. A real-world example involved an unpatched vulnerability in a widely used server operating system. Attackers use this flaw to gain administrative rights, install a backdoor, and exfiltrate sensitive data, all without triggering traditional antivirus tools. The exploit was publicly documented, and a patch had been released weeks earlier, but the organization had not applied it. This highlights the importance of patch management. Timely patching is one of the most effective ways to prevent operating system-level exploits. Organizations should implement automated patch deployment and maintain an inventory of all operating systems in use, along with their update status. Another critical defense is OS hardening. Hardening involves removing unnecessary services, disabling unused ports, enforcing strict access controls, and applying configuration best practices. Operating systems should be deployed with secure baseline configurations and monitored continuously for unauthorized changes. Using role-based access and least privilege principles further reduces the risk of exploitation. Now let's look at web-based vulnerabilities. These are flaws that exist in websites and web applications, systems that users interact with through browsers. Because web applications often connect to databases, accept user input, and run complex scripts, they present a wide attack surface. One of the most dangerous web-based threats is SQL injection. Structured query language injection happens when an attacker sends malicious input into a form or URL in order to manipulate a database. Instead of treating the input as a user value, the system interprets it as part of the SQL command. This can allow the attacker to read, modify, or delete data. For example, a poorly secured login form might accept a username and password from the user and pass them directly to the database without proper validation. An attacker could enter a command that bypasses authentication entirely or extracts all records from a user table. This kind of attack has led to massive data breaches involving financial records, passwords, and personal information. SQL injection can be detected through automated web scanners, manual code review, or behavior monitoring. To prevent it, developers must use input validation, sanitize user input, and apply parameterized queries or stored procedures. Web application firewalls can also help block known injection patterns. Another major threat is cross-site scripting, often shortened to XSS. This vulnerability occurs when an attacker injects malicious scripts into a web page that is later viewed by other users. The scripts are usually written in JavaScript and are designed to steal session cookies, redirect users, or deface content. There are several types of cross-site scripting, including reflected, stored, and DOM-based. Reflected XS is triggered when a user clicks on a malicious link, and the server immediately reflects the malicious script back to their browser. Stored XSS is more dangerous because the malicious script is saved on the server and delivered to any user who accesses the affected page. DOM-based XSS occurs when the vulnerability exists entirely in client-side code, often through insecure use of the document object model. A real-world case involved a popular forum platform that failed to sanitize user-submitted posts. Attackers inserted malicious scripts that ran every time a user visited the thread. These scripts captured user session data and sent it to an external server, allowing attackers to hijack accounts without detection. To prevent cross-site scripting, developers must validate and sanitize all user input, especially before displaying it on web pages. Content security policies can limit which scripts are allowed to run, and security-focused development frameworks can reduce the risk of introducing these flaws. Testing tools and static code analysis can also flag potential issues before they go live. Both SQL injection and cross-site scripting demonstrate how dangerous improper input handling can be. They also show that web applications, while essential to business operations, must be carefully designed and continuously monitored for threats. As you prepare for the Security Plus exam, make sure you understand the differences between operating system-based vulnerabilities and web application flaws. You may be asked to recognize an example of SQL injection or cross-site scripting, recommend appropriate defenses, or identify signs that a vulnerability is being exploited. Watch for details like user-controlled input, database queries, or dynamic web content. These often signal that input validation is your first line of defense. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.